Just look at them clouds, ladies and gentlemen. Look at them clouds and feel the coolness. Last week it's been over 30 degrees and today it's just like a sudden drop and it's now at like 22, 24. I was actually on the bus coming in, I was actually cold. I've done my sleeves back up. Stand by my opinion that it never really has to be over 20 degrees, you know? It's also bizarrely quiet this morning. I don't know why. See? Barcelona? That's cool too, right? It's going to be the fourth time this week that I haven't worked my lunch. I hardly ever head out the office at lunchtime, but this week I've done it every single day. I've got to go pick up my shirts, which have been delivered just up the road, which means that I don't really need to... I thought this woman was taking two birds for a walk then, but they just happened to be like on a doorstep and she stepped out, so they walked away from her. Picked up my shirts at lunchtime. I wasn't really in the mood to talk at lunchtime. So, you know when you have kind of like a slump in the middle of the day and you're like, oh, I've got to go to lunch, and then you come back and you're like, oh fuck, I don't want to come back, and then you're like, come on, get back into it, boy. Fortunately, had a very productive morning and a productive afternoon. We are starting to integrate with the beast that is the legacy old system we're trying to replace. This service is a soap service and its own wisdom is invalid, which is incredible. In other news, ladies and gentlemen, I've been investigating what it takes to manage and control Service Fabric and Azure cloud container things, which is much easier because it's actually a lot cooler, so it doesn't actually burn my brain up just trying to think about this kind of stuff. What I've been looking into is it's relatively simple to control both. Well, there are APIs that make it possible to control Service Fabric and Azure, so I can spin up separate Azure instances onto. There's like specific documents on how to do this kind of stuff, but at the top of the document it says this is not recommended. This is not an easy thing to do, and it's complicated. And I'm in a weird position because I could just have a blanket. You can't configure how. Basically, the process that I'm trying to do is quite expensive, computationally expensive, which is why it really pays to run it in separate, multiple threads. Depending on the type of mode that you use, it will take longer, therefore it needs more threads to run in parallel, etc. If you run it on separate machines, then the more threads you can have, easy peasy lemon squeezy. Problem is, running it on separate machines incurs a higher cost, which means that the service becomes more expensive, / it costs me more money, whatever. The ways to manage this are to essentially allow users to limit how many resources. Say they want to test their stuff, but they don't really want it to come back fast. Then they could just put it on with like a minimum amount of threads, and then it just runs through, happy days. Or you could be someone who really wants your results out. Well, I want my results out as fast as humanly possible, and you're willing to pay for that. Then you will be able to basically say, do whatever the hell you want. The problem obviously becomes when you have multiple users. I can set up a blanket auto-scaling rule. So for every however many messages on the service bus, scale another instance out, etc. And then it'll scale down and up based on load. I can add limits, and I can add when to scale, when not to scale, all that kind of stuff is easily configurable. That's the recommended way of doing it, but it means that I don't have the kind of control over it that I want, because I can't have a heavy user on at the same time as a thingy user, a lower user. So I'm toying around with the idea. I'm going to sit with auto-scaling for now, but I'm toying around with the idea of adding my own manual type of scaling. And this is because essentially what I want is a single node. Let's say I have an MS build node. I have a single node can do one MS build and 3 .NET runners, right? So if I plump on 100 MS builds, and my user says, hey, I want to run this on only 10 threads, then I can spin up 10 threads. But that means that I have the capacity to run 30 .NET builds on the background. So the next user that comes along and says, I want to use 10 threads, I don't need to spin up another 10 services. I just kind of basically allocate, even though I don't have control over which server you use, I allocate resources to it. And then as soon as I realise that I actually have a user on the platform who now wants .NET 1 and they want to run on 100 services, then I need to spin up however many more MS Build services that can then do it. To be able to manage that kind of load. The complexity there is I obviously need to know what my users want. I need to know how heavily loaded the platform is and how many messages are on the buses, basically. And it's a case of being able to know what the users want. I need to know how many nodes I have on the network. I need to know how many services that those nodes can run concurrently based on what type of builds they have. I need to know what kind of builds the user has, and I need to. There's a lot of complexity there, and there's a lot to go wrong. But it will give me what I want, because the other way of doing it is basically saying, hey, I've got 1,000 messages on the queue. Let's spin up another 10 servers to deal with it, which isn't great if I have. Say there's only 3 messages on the queue. That's a bad example. It's not necessarily great because it means that my let's say that someone says I want to use 10 servers, and or I don't let them do that. Let's say someone does that. They have a big bulk test run they want to do. They don't care. They don't want the results back fast. But then my service goes, hey, they've just put 10,000 messages on the queue. Let's spin up 5,000 nodes, which would cost them, well, it would cost significantly more. Well, I don't know, actually. I wonder if it costs the same, like running that computation for a long amount of time. But either way, it would be cheaper if I would be able to manually control the fact that maybe spinning up another 10 isn't going to speed up that person. Maybe it's not. And if I have manual control over that, then I'll be able to do it. So let's say, for example, MS Build come along, they hit the queue with 10 messages, they get picked up by the servers. Someone else comes along and adds 30 messages onto the queue. The platform might go, oh Christ, we need another 10 boxes to deal with this, when really there's space on the messages for it. Does that make sense? So yeah, basically it's possible. There are APIs for it, both for managing Service Fabric itself and for managing Azure, so that's not too bad. It's going to be fun, ladies and gentlemen, but I've basically decided that I know my technology stack, which I kind of knew anyway, but I wanted to make sure it was possible. I know my technology stack. All I need to do is architect it out, make sure it works nicely. Again, I have an idea. I'm going to have some kind of presentation. I'm going to have some kind of orchestrator, which is going to be like responsible for figuring out what needs to be done, that then needs to essentially lay off to something else, which is responsible for managing how many nodes are running on the network. Well, it'll be automatically scaling for now, so maybe that's not required. But yeah, so the nodes will be automatically scaled up. And they need to run the nodes. I need a queue in the middle. Oh no. Where's the wind? Where's the wind? I thought Laura was woken up, sorry. Very windy, I thought I'd woken up Laura there. Yeah, basically, I know the energy stack, I know it's possible. I just need to figure out a good way of managing it all. For example, if I have one big queue that's funneling into the thingy, how can I prioritise what messages are going through that queue? If I have a big user that's just hit my services with 20,000 messages, and I've not scaled up to deal with them, then I'm going to have 20,000 things on the queue until they manage to get through the system. So how do I manage that? Do I have separate queues per person? Do I have the ability to search for the user? I don't know. There's lots of interesting questions about this kind of stuff. There's a lot of kind of threading and optimization and prioritization that needs to be managed. But yeah, I'm figuring out how to do it. I'm also thinking about tactically dropping .NET Core in certain areas. So for example, that node that's controlling the network, that'll be full fat framework. Because it basically has to be, because the APIs don't suit it, and I'm not going to sit and wait for them to port it. There are a couple of instances where .NET Core isn't ready yet, or it's in .NET 2.0 preview and all that kind of stuff, and it's a case of I just have to kind of wait for that to become available to do it, or jump in with a different framework with the aim to thingy it again, bring it back down to core in the future. But that's that. Anyway, it doesn't really. I don't need all of it to be .NET Core, just the bits that matter. And to be fair, it makes sense for certain parts of it to be full fat anyway, because then .NET Core is it'll be easier to run a .NET Core instance inside full fat than it will be full fat and .NET Core, because full fat framework basically by definition doesn't run on a Linux box. So why have my .NET Core instance running on a Linux box? It doesn't make any sense. Rambled enough. My body clock's like basically locked on to go to bed at 12:30 now. I'm waking up at 6, which is good. But yeah, I've been rambling too long. I shouldn't do this on these videos. Have another cooler Friday. Thank God. Maybe that's what you need. You need like, because normally I'd complain if it was 24 degrees. I'd be like, it's a bit too warm. Doesn't really need to be above 20. But since it's been 32, like, I don't mind it. I can handle it. Waiting for my hay fever tablet to kick in a little bit, but otherwise, all is well. Otherwise, guys, on my whistle-stop tour through architectural designing my new platform, I have one more problem I need to solve, and that's fairness, which is difficult to solve with queues. Let's say, for instance, a user on my platform wants to use 10 threads. We spin up 10 threads, we deal with their messages as they come through. They add 10,000 messages to the queue, let's say, for example. I have another user that comes along just after that. They just want 2 threads, or 5 threads. They want 5 threads. And then they put their messages on the queue. They've just got 10 messages on the queue. Because it's a queue, those 10 messages will get processed after those first 10,000 messages. Like, if it was a different type of build, i.e. .NET or MS build, I'd be able to run them in parallel. That'd be fine, because I'd be able to pick up the messages based on that. Essentially because it'll be a different message, but I can't have a different message type per user. So how do I manage that? I could spin up a queue per user, but then how does my microservices manage that at the low down level? I'd have to assign 10 different microservices to... It complicates things significantly if I have different queues per message. In an ideal world, I just slam these things onto the queue and then I allow the microservices to take it when they can. May have to like generate some kind of logic that that's what I'm going to try and solve. It's relatively difficult enough setting it up so that I can do MS build and .NET build, for example, in parallel. But yeah, going one step further and doing it on a per user basis is even harder. Because if I, like I say, if I generated an extra 5 threads, let's say, so I've got someone using 10, I want someone who wants 5, I spin up an extra 5 machines, those 5 machines are just going to be dedicated to the first 10,000 messages on the queue. Unless I find a way of telling those machines which user they should listen to, and then they basically cycle through the queue until they find their user. Then I need to figure out a way, this is why I need that auto-scaling thing, because then I need to figure out a way of updating those servers. Say my first user wants to up their number of threads, to update who that user should listen to. As you can see, that gets messy fast, so that's my problem I'm going to try and solve today. I've done quite well at solving a problem a day, so what a heavy day, ladies and gentlemen. We've been mapping stuff left, right and centre basically. We're now kind of mapping our nice new world representation of everything into that heinous, hideous shit that we're trying to basically replace and integrate with by this grim soap service. Back today because a couple of people left, like contractors, came to the end of their contract, so I was talking for a bit after work with them. Basically, ladies and gentlemen, the problem I have is I want to reuse my consumers, but my consumers aren't supposed to be reused. I need basically a consumer per user. That's not a very efficient way of managing space and computing thing. Because it basically means I'm going back to the image of having a different consumer per workflow rather than having one big consumer that's able to do everything. Maybe that's what I shouldn't have. Maybe that's the problem. It's such a pain in the ass. There is such thing as, like, you can prioritize queues, which is kind of like what I want, basically, because I just put everyone, more or less what I want. Basically, the way you do prioritization on queues is you have 3 different queues, and you have high priority with more consumers, medium priority with less. So, in my world, that's one user has their own queue, which in turn has to have, by design, its own dedicated consumers, because otherwise, maybe maybe what I'm thinking about here is slightly off, where I need, like, my idea of the thing that sits on the end of that queue isn't the actual testing environment. The testing environments exist, and I have consumers that sit behind them, sit like in front of them, and then are able to pull. So I might be able to, okay, right, let me redraw. The reason I'm thinking of this quite weirdly is because I'm thinking of these instances as virtual machines, and they aren't virtual machines, they're app services. Maybe that's why I'm thinking of it a bit strangely. So really, because it's an app service, it doesn't actually matter whether or not I share boxes between users. Because it's an app service. It's like, I don't care what the hardware is, I just care that it's running. I think. I'm going to have to look into how Service Fabric manages on Azure. I don't know whether or not you need it to be on multiple machines. So you kind of do have virtual boxes. I'll have to investigate that. And I need to draw, but I'm making dinner. So it turns out we had frozen sweet corn. So, happy days. Solved it, ladies and gentlemen. The problem is that I have to take control of scaling. I can't auto scale with this model. Basically what I was doing, the thing I was kneecapping myself was basically having a generic queue and like one singular queue, and on each node one singular handler, which obviously isn't going to be the case. I'm going to have multiple handlers on each of the on each of the endpoint machines. So if I have a concept of controlling my own scaling, then it suddenly works itself out, because as a user comes onto the platform, I can generate a queue for them. Relatively complicated, but I can generate them a queue that's dedicated for their tasks. I can generate, then that machine is then responsible for auto scaling the rest of the platform. So it knows how many concurrent threads that user requires, how many it wants to have, and all that kind of stuff, and is therefore able to instruct the other nodes how they work. So on each node, I'm going to have to implement some form of API, this is the wishy-washy bit, but this thing will basically go, right, I've got this many servers, I've got this many concurrent nodes, I've got this many available threads on that specific type of compiler. Do it. They go and do it, they go and run, happy fucking birthday, everyone's happy, that's cool. If I've got loads of space, I will spread them out across multiple nodes if possible. If I have, say, like three instances already running their spare nodes on each of those instances, I'll spread them across the instances. Otherwise, we generate singular instances in order to meet demand. And yeah, I basically just need some form of API which will be able to communicate with each of the consumers. So when I spin up a new consumer, a new evaluator, I'm able to tell each consumer individually which queue to listen to. Then there will at only one time say I want 3 concurrent users. As a user, I want 3 concurrent threads running. I'll be able to say, my manager will basically ensure that I have that available, and I'll spin up, even if they're on their own shared box, I'll spin up 3 separate handlers which will be able to deal with it. Then I'll probably end up having an instance. No, that's foolish. The issue there obviously is that it will take me longer to spin up each box, on the basis that the box has to spin up. I then need to tell it what to download, what files it needs to have access to. I need to spin up the Docker containers and all that kind of stuff before it can start processing anything. But if there are already things running on the platform, that won't be as necessary. And obviously that can all be done asynchronously. As soon as you hit my platform, I'll know all that information, so I'll be able to asynchronously spin all that up so it's ready for you, while other things are being processed in the background. And also, if I'm spinning up a node, say you asked for 10 nodes and I've got, 10 things, I've got capacity for 8, those 8 can run while my other 2 catch up, you know? Solved it. But I don't get the luxury of being able to have auto scaling, as they just look at one queue and it doesn't matter. It was a good job I thought about this now, so. Well. Not only did I again forget to do my video yesterday, I uploaded it. Today, I uploaded it, forgot to schedule it. Haha! So it's not going up till tomorrow now, god damn it. Likewise today I've been equally shitty, but I have now officially like drawn out all of the different microservices. Most of the important microservices that my platform is going to require. There's like a couple of ones like party services and stuff like that I haven't drawn yet, but that's not key at the moment. It's pretty cool. It's pretty cool. I just need to figure out well, names. Names of them is going to be a bit of a pain, but I think I just need to jump into it, to be honest with you, which I may end up doing. Otherwise, we've literally just had a slobby day. We went out and picked up some food for the weekend. We bought our loaf of bread, which we always buy for the weekend, and we just watched The Legend, which was like about the craze, which was alright. Very long though. It's nearly midnight and we're heading to bed. We've got to get up relatively early because we is doing stuff with Buff and Bun, hopefully. Don't know yet. Potentially. I believe we are. We've got a plan, we just don't know how we're going to get there. Or what time. We'll figure it out. You okay, Graham? Are you confused? Why is all the contents of my cage around the place? Is that my tube? What the hell? I have a feeling that actually she can't do that much damage if she's left on her own. I don't think she can, since she was out for an hour, I don't think she can get under things like the settee or anything like that. Problem is if she goes over there and starts to try and fucking eat her food, which she could probably get at, which she's getting at. Why is the Bay is next door playing SimCity for a change? We were going to go out for a walk today, but the rain was lashing it down, and it's now calmed down a little bit, which is irritating. But yeah, we were going to go for a walk with Beth and Ben. We were going to go around like a big lake river thing, so it'd probably get a bit marshy in the rain. So instead, we're going to go air hop, which is like a big trampolining area. So it's going to be pretty good fun. Otherwise, Laura's been distracting me with the prices of custom built computers, as I've been looking to upgrade Atlas at some point, and it's like more than a longboard money, which is what's putting me off. So, but yeah, like it's one of them things where I want to custom build a machine. I don't necessarily want a gaming computer, but I want to custom build a machine that I can use for development and like with multiple. I want a tank basically, and my current laptop isn't a tank per se. It's fast and it's powerful, but it's not a tank like Atlas is. And Atlas is like 5 years old now. The case she's in also makes it really difficult to upgrade her. Although I could arguably take the motherboard out and put the motherboard in a different case and upgrade that case. Maybe that's a better way to do it. Don't know. Yeah, so I've been looking at that. Otherwise, last night when I was going to sleep, I realised that while I've planned my platform, I've kind of lumped too much into the middle bit, the brain bit. I'm going to start separating that out and try and design that bit, because I'm trying to think of a clever way of storing. Because now at the moment, now I'm moving to the cloud, it's going to need to persist more information, so there's like a little bit more complexity in like how much all of my... At the moment it's split into different services, but those services will have to store a little bit more information, and I kind of want it so that if a service goes down, then you don't have to have them all running in order to run it and stuff, but... Oh, we shall see. I think that might be a little bit of a pipe dream actually. I have like a user service, I have like a source code service which is able to keep track of the code and what's changed and all that kind of stuff. And then that liaises with the thing that does all the testing. So yeah, basically that's what I'm doing before we go bouncing a boot. Oh, didn't press stop there. You know what, it was pretty good. We were half expecting it to be a bit like crap because we'd be the oldest people there, but we weren't actually. There were quite a few like relatively old people. There was a lot of like 10-year-olds. Basically just trampolining, like it's just a big room of trampolines, and then there's like little areas where you can do other things. I feel like my back took a bit of a beating, which is a bit not great, and my shoulders are feeling a bit pain as well, but I don't know why. It was really good fun. It's just probably one of them things that you would go at like 9 o'clock at night to try and avoid all the kids rather than going at midday on a lunch on Sunday. Otherwise though, Laura and I have been talking a little bit today. We've been playing, well, Laura's been playing SimCity and I've just been like on my laptop next to her in the office. We've been talking about how we both feel relatively like stationary, like we're not really getting anywhere. I feel like it in particular because I feel like I'm trying really fucking hard and I feel like I'm running really, really fast, like all the time. but I'm not getting anywhere. Laura like jokingly said it's because I haven't changed job recently, which is hilarious. It's like little things like I really want a longboard. Like there are a lot of things I want that I'm going to get at some point soon, but I want them and I'm not getting them. So it feels like I'm like stationary, like at this like point where I can't really progress forward. You know what I mean? I really want a longboard. Laura's basically talked me into looking into computers again. I'm at the point where Atlas is struggling a bit. Like every now and again she just fails when she's editing a video. She's like slow to boot up. She's alright when she's running, but you can tell she's getting old. She's 5 years old now. The problem I'm at the moment is that I can't do my Docker stuff on it because it just doesn't work, basically. Some of that could be solved by upgrading to Windows 10 Pro. But yeah, what I basically need is I'm going to start migrating my platform to a distributed system where they're going to be running on multiple different machines, so that I can scale certain systems. It's something I've always planned to do. My project's been designed in silos. They're basically, I'm just going to start putting them out there, and basically it's going to get to the point where Atlas, my laptop, is a beast, brilliant for programming, but struggles to run the platform, and that's before I'm starting to separate everything out into separate services. Although it might be a little bit better because I'm running it, in theory, in like actually running it on it rather than debugging through it. But yeah, so my laptop struggles. What I need is like essentially a tank, like Atlas was. When I bought Atlas, she was such a beast, and she still is a beast in some respects. But yeah, so I've been looking at a new PC, and I'm in the position where both of those things cost. Well, the longboard will cost about over £1,300, probably 1,500-ish, maybe a bit more for an Evolve longboard. But the value proposition is that I can get to work faster in the morning. It'll be a nicer commute because I'm not in a car. It saves me petrol, it saves me bus, as long as the weather's nice. The value proposition for my computer is that my computer is going to start holding me back soon, and I need to get around that somehow. So Atlas is due an upgrade, but it's difficult to justify it because I've basically been so lucky with my laptop. I'm in the position where and also I don't really use Atlas much, partially because of that reason, because she's not that powerful, and partially because I'm doing work on my laptop all the time because I want to do it at work, but I'm not doing programming at work anymore on my own laptop because I don't have time and I want a break. So what I'm thinking is, yeah, I don't know. Otherwise, my own project, I've had a bit of a break this week, as I've been doing some architectural stuff, and I'm kind of like daunted by the fact that I need to start separating things out, which is just a pain in the arse because I need to move things into different, because at the moment I've got different projects inside a solution act as different services. What I'm going to end up doing is separating that out into different solutions. Each one of those things will be an individual solution, each one of those will have individual projects within it. I'll be separating out things like core contracts, core like infrastructure stuff and all that malark. It's going to be fun, but what I think, basically, yeah, like I feel like I've been working on this thing for like 2 years now, 2 and a bit years, and nothing's come out of it yet. So what I'm going to do is I'm going to continue to progress the old platform on my laptop at work in time that I've got available to me, and then I'm going to be working on migrating all the platforms over on Atlas for a little bit. I'm going to see how it works, me working in there, working in here. The advantage of moving to this microservice architecture is that I can actually work on separate different services at the same time, and separate branches and stuff. So it might be a little bit better working, because the main problem is that I have to transfer code through the build server between the two, and that's just awkward compared to things like Google Drive, where it's just instantly synced across. So yeah, basically all these things, and like all week this week I can't stop without concentrating on something. I can constantly think, I can't just put it down. So basically what happens if you feel like you're not going anywhere on a treadmill, you start to run faster. That's what happens. So tomorrow we're going to hit it. Well, yeah, tomorrow we're going to hit it like a brick. We're going to just absolutely accelerate, and we're going to be focusing hard. We're going to be making the most of work, doing little bits on my laptop, and then I'm going to start setting up all of the services on my main computer when I come home, and I'm going to start actively migrating it to this platform. And the aim of the game is for it to be, I've said this before, but that it's more or less finished. It's at its limitations to run on one single machine. I've done the proof of concept, it's all working in .NET Core, it's all nice, it's way better than my original one was from Final Year Project. Fucking way better. What I need to do now is start building it into actual separate services, running it in Service Fabric. I now know how to do that. I didn't know how to do that a year ago. I now know how to because of what I've done at work. And I'm just going to start pushing and pushing and pushing. I'm going to start trying to put it into the cloud, and I'm going to try and get it to the point where someone can sign up, sign in, and test their own stuff with my platform. That's the plan. How I manage things around that is going to be interesting. One of the problems I have with not being able to test it on my laptop is I could just host it all in Azure straight away, but I think it's going to be pricey. So one of the first things I'm going to introduce in is being able to target specific parts of the program rather than, at the moment it's just a bulk test. I'm going to be changing that. But yeah, so basically we've feeling a bit frustrated because it feels like we're not moving anywhere. Like Laura's obviously like doing stuff at work, but we haven't moved flat. We've kind of been here for a long time now. All these different things, it feels like we're kind of like in a staging point before the next point in our lives. And we need to start moving and fighting for those things a little bit more aggressively. Well, anyway, we're halfway through the year now, so now's the time. Now is the time. I think I'm going to end it here, ladies and gentlemen. I feel like I've been vlogging for a long time for some reason. Don't know why. Whoa. Yeah, that is basically the plan. That's what we're going to be doing. We're going to be fighting, we're going to be hustling, we're going to be getting shit done. Thanks for watching, ladies and gentlemen. I hope you enjoyed this video. I'm going to try and get this video out a little bit more promptly than I did my last video. I'll catch you later.